The key to the power of DNA computing is that it allows for testing of each of the trillions of strands simultaneously. In 2003, Israeli scientists led by Ehud Shapiro at the Weizmann Institute of Science combined DNA with adenosine triphosphate, the natural fuel for biological systems, such as the human body. With this method, each of the DNA molecules was able to perform computations as well as provide its own energy. The Weizmann scientists demonstrated a configuration consisting of two spoonfuls of this liquid supercomputing system, which contained 30 million billion molecular computers and performed a total of 660 trillion calculations per second. There's the notation for it. The energy consumption of these computers is extremely low. Only 50 millionths of a watt for all 30 million billion computers. So you won't be able to see the top of the next page, but DNA computing, each of the many trillions of computers has to perform the same operations. Well, this is the downside of DNA computing. Each of the many trillions of computers has to perform the same operation at the same time, although on different data, so that the device is a single instruction multiple data architecture. This is the flaw I was talking about with pixels. While there are important classes of problems that are amenable to a SIMD system, for example, processing every pixel in an image for image enhancement or compression, and solving combinatorial logic problems, exactly what I spoke about the flaw with pixels before having read this. Now, one of my weaknesses is that I read very slowly, and it's usually because I read and always almost try to find my own conclusions based off of what I've read versus just taking in the information. So by the time I presented my argument or my theses, hypotheses on what the pixel shall be, I hadn't read all of this yet. Anyways, it is not possible to program them for general purpose algorithms in which each computer is able to execute whatever operation is needed for its particular mission. Note that the research projects at Purdue University and Duke University described earlier that use self-assembling DNA strands to create three-dimensional structures are different from the DNA computing described here. Those research projects have the potential to create arbitrary configurations that are not limited to single instruction, multiple data. That's crazy. This technology is probably the reason we have self-driving cars right now. It's very likely that it hasn't been perfected, but self-driving cars are a thing. They are able to make million trillion calculations per second, reading the road, reading everything around them. Now, if this computing power is placed into phones, into cameras, or into what the camera will be in the future, the things we'll be able to do, the world will be able to create will be limitless. It's already happening with VR and AR, but the day the VR and AR are no longer a layer placed onto the post creation and rather simultaneously created without needing extra what to be able to create it, just simply instructions onto the device that is creating the recordings. We're gone. We're living in a whole new world. Everyone will be living in their own world.